This function has more letters than numbers. Amazing. That's right. We can do some English today. So we're given this function, x cubed plus ax squared plus bx plus 2, has turning points when x equals -1 and x equals 3. Find the values of a and b. Alright, so let's have a think first. So this function is a cubic, highest power of 3. The coefficient is 1, so it is a positive cubic. So it will look something like that. Beautiful. And it has turning points when x equals -1 and positive 3. Cool. So the turning points, what additional information does that give us? Right, so turning points, the min, the max. Well, we know the gradient at a turning point is equal to 0. So gradient at turning point is 0. Now, that's pretty useful information, because if we have the gradient function, we can substitute in 0 as the gradient and our x values in for x, and we'll be left with equations in terms of a and b. Right, so we're reducing the problem. So step 1, find the gradient function. So f prime of x, the derivative of x cubed is 3x squared. Right, we take the power of 3, multiply it out the front, then subtract 1 from the power. The derivative of ax squared with respect to x, remember, so a is a constant, so treat it as a constant. We take the 2, multiply it out the front to give us plus 2a, then we subtract 1 from the power, leaving us with x to the power of 1, or just x. Derivative of plus bx, so b is a constant, so we know if we have a constant times x, the derivative is just that constant, so plus b. And finally, the derivative of plus 2, the derivative of a constant is 0. As it is constant, it is not changing. Oh, so we don't need to write plus 0 at the end. Great, we have our gradient function. Now let's use the information that's given, right? So turning point has a gradient of 0. So our gradient function will be equal to 0. Like so. Awesome. Now, looking at this, it's one equation, and I see 1, 2, 3 unknowns. So that's not very helpful. In other words, we can't solve it yet. However, we are given 2 x values of the turning points. So let's use that information now. So when x is equal to 1, -1, this whole equation becomes 0 equals 3 times -1 squared plus 2a times -1 plus b, which simplifies -1 squared is +1, so 3 plus 2a times -1 becomes -2a plus b. Alright, can we solve this? I see 2 unknowns in one equation, so no, we still can't solve it. However, we can also use when x is equal to 3. Right, so let's try that. So substituting into our gradient function again, but this time with x equal to 3. So 0 equals 3 times 3 squared plus 2a times 3 plus b. So simplifying that, 3 squared, 9 times 3, 27, plus 2 times 3 is 6, so 6a plus b. Now let's have a look at that equation. I see two unknowns still. However, now we have two equations and two unknowns, which means we can simultaneously solve. Alright, when the number of equations you have equals the number of variables you're solving for, if it has a solution, you can solve. Alright, so let's do that now. A few ways you could do this. I'll show you, I guess, the algebraic method that I would personally use. So we can just write the equations above each other to make it a bit easier to read. And we'll do what's called elimination, where we effectively add or subtract the equations from each other to eliminate a variable. So I see both equations have plus b on the end. So if I subtracted one equation from the other, we would eliminate b, and we'd be left with one equation and one variable, right? Variable a. So let's do 1 minus 2. So I'll subtract the equation 2 from equation 1. So let's just read it down in columns because it's organized that way already. So 0 minus 0 on the left gives 0. 3 minus 27 gives minus 24. Minus 2a minus 6a gives minus 8a. b minus b gives 0. Great. So again, now we have one equation. We'll add 8a to both sides, and then divide both sides by 8. So a would equal negative 3. Alright, and then to find b, we can substitute a equals negative 3 into either equation 1 or equation 2. So I'll use equation 1. So 0 equals 3 minus 2 times a. This time a is negative 3 plus b. So 0 equals 3 minus 2 times negative 3. So that's plus 6. That's plus 9. We'll subtract 9 from both sides. So b equals negative 9. Alright, so let's go over that one real quick. So it was a cubic function with some unknown parameters a and b, which we had to find. However, we were told what the turning points were, the x values, so we found the gradient function and we equated it to 0, which is an achieved skill. Because we've acknowledged the turning points have a gradient of 0, so we found the gradient function and equated it to 0. However, we realized there were 3 unknowns in that equation, so not very useful. However, we then went on to use the fact that the turning points were at x equals minus 1 and x equals 3. So we substituted those into the gradient function separately to get equation 1 and 2. And doing that is a merit skill. So we had 2 equations with the 2 unknowns, a and b, so we can then solve it. Lots of different ways you can solve it. In this case, since the format of the equations are similar, right, we have 0, we have a constant, we have the a term, we have the b term. If we put them like that, one above the other, we can then easily use elimination. Alternatively, you can use your calculator, use the simultaneous equation solver there. But after subtracting 2 from 1, equation 2 from equation 1, we found a is equal to negative 3, We then substituted that back into equation 1, and we found b. So finding a and b accurately is the excellence component.